Let's end this lecture by talking about some applications of parabolas. The main applications of parabolas involve their use as reflectors of sound, light, radio waves, and other electromagnetic waves. If we rotate a parabola in a three-dimensional space about its axis, the parabola sweeps out a paraboloid of revolution. If we place a single source at the focus of a reflective paraboloid, the signal reflects off the surface in lines parallel to the axis of symmetry. This property is used by flashlights, headlights, searchlights, microwave relays, and satellite uplinks. The principle works for signals traveling in reverse direction as well as signals arriving parallel to a parabolic reflector's axis are directed towards the reflector's focus. The property is used to intensify signals picked up by radio telescopes and television satellite dishes, to focus arriving light in reflecting telescopes, to concentrate heat in solar ovens, and to magnify sound for sideline microphones at football games. So we're going to end this by working on an example that deals with this paraboloid of revolution. We have the reflector of a television satellite dish is a paraboloid of revolution with diameter 5 feet and depth 2 feet. How far from the vertex should the receiving antenna be placed? We want to place that receiving antenna at the focus point. And so we have to figure out the p-value based on these dimensions to figure out where to place the focus. Let's go ahead and draw what our parabola looks like in the XY system with these given dimensions. So this is the illustration of a paraboloid of revolution with a diameter of 5 feet and a depth of 2 feet placed within the XY system with the vertex at 0, 0. This type of parabola is represented by this equation when we have x squared equals 4py. And so what we need to do here is we have to figure out our p-value. That's going to tell us what where to place the focus. We could solve for p if we have an xy point. So let's go ahead and identify an xy point that is on this parabola. So we have two points here, and we want to figure out the p-value. So let's go ahead and plug in the point. We're going to plug in that point into the x and the y value, and then we're going to solve for p. Okay, so we plugged in a point, solved for p, and that gives us the distance of from the vertex that we need to place the focus. So we're going to place that focus about right here, and that represents 0.78125 feet. All right, I will be seeing you in class. Bye.